Hey everyone, you ever look at a math problem and just feel like you're trying to read some ancient secret language? Well, today we're not really doing math. We're becoming code breakers, and we are absolutely gonna crack the trigonometry code. So let's get into it.
Okay, here's the kind of code I'm talking about. Just look at this thing. We're given a pretty simple equation to start, but then we're asked to find the value of this monster with powers of 8 and 6. At first glance, it seems impossible, right? Like it was specifically designed to make your brain hurt. This is exactly the kind of problem that trips people up. But what if I told you there's a hidden key? Because that's the big secret here. It's not about memorizing hundreds of different formulas. It's really about learning to spot a few core patterns that just show up over and over again. These crazy-looking problems, they're just wearing a clever disguise. And our mission today is to rip that mask right off.
So here's our mission plan. We're going to start by looking at 3 fundamental patterns I call the power of 1, the conjugate trick, and the special case. Then, once we have those tools, we're coming right back here to unlock that final puzzle together. By the end of this, you're going to have your very own Codebreakers toolkit to take on these problems yourself.
First up, pattern number 1, the power of 1. I call this the master key of trigonometry because, and I'm not kidding, almost everything else can be unlocked from this one single powerful idea.
And here it is. Sine squared plus cosine squared equals 1. This is the Pythagorean identity, and seriously, it is your absolute best friend in trigonometry. It's the first thing you should be looking for anytime you feel stuck. It lets you swap sines for cosines and cosines for sines, which is an incredibly powerful move in this game.
And what's so cool about this master key is that it can instantly create other keys. Just take the original identity, divide everything by cosine squared, and bam, you get a brand new identity. 1 plus tangent squared equals secant squared. Do the same thing, but divide by sine squared, and you get a third one. Just like that, our one key just gave us 2 more. 3 powerful tools, all from one simple place.
So how does this actually work? Let's say you're looking at some messy expression. First, you spot a pattern you recognize, like 1 plus cotangent squared. You know what that is. You immediately swap it out for cosecant squared. Then maybe you see another one, 1 minus cosine squared, and you know from our master key that that's just a disguised sine squared. So now you simplify. You've got cosecant squared times sine squared, while since those are just reciprocals of each other, they multiply to 1. The entire complicated expression just collapses into nothing. Boom, problem solved.
All right, let's level up. Our next pattern is a little more sneaky, but man, is it satisfying when you use it. I call it the conjugate trick, and it's all about turning subtraction into division. Sounds weird, but stick with me.
So this trick actually comes from those 2 other identities we just made. If you rearrange them a bit, you get things that look like secant squared minus tangent squared. Now, this should look familiar from algebra class. It's a classic difference of squares, which means we can factor it into 2 pieces. Secant minus tangent times secant plus tangent. And because it all came from an identity, we know the whole thing still equals 1.
So here's the crucial part, the aha moment. If you have 2 numbers that multiply together to equal 1, what does that mean? It means they're reciprocals of each other. They're just the flipped version of one another. And that is the entire secret to this pattern.
And this is where it gets crazy powerful. A question might ask you, if secant A minus tangent A equals 1/3, what is secant A times tangent A? Before, you might be totally stuck. But now, you know the answer is just the reciprocal. You just flip the fraction. The answer is 3. Done. No algebra needed. It is that fast.
Okay, on to our third and final pattern. And this one feels like a straight-up magic trick. It's a special case you can learn to spot, where the answer is literally hiding inside the question itself.
The whole thing is built on a super simple rule from algebra. If you take a positive number, let's call it x, and add its reciprocal, 1 over x, the only way that sum can equal exactly 2 is if x itself is 1. Think about it. 1 plus 1 over 1 is 2. Try any other positive number, like 3. 3 plus 1/3 is 3 1/3. It only works for 1. So how does this show up in trig? Well, think about it. Cotangent is the reciprocal of tangent. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. So if you ever see any of these pairs added together and they equal 2, you immediately know the value of that function. If tangent plus cotangent is 2, then tangent has to be 1. It's a massive shortcut.
All right, code breakers, this is it, the moment of truth. We've got our toolkit, we've mastered the power of 1, we've got the conjugate trick, and we know about the special case.
Let's go back to that monster problem from the very beginning and unlock this thing for good.
Here it is again. It looks just as intimidating as it did before, but this time is different. We're not just staring at it anymore. We're scanning. We are actively looking for the patterns that we know are hidden inside. We have the keys. Let's use them.
Okay, let's break this down step by step. First, let's look at the expression we need to solve. Notice the pattern of the powers, 4, 6, 8? That's a perfect square. It simplifies to cos 4x plus cos squared x squared. Okay, good start. Next, let's look at the clue we were given. Sin x plus sin squared x equals 1. If we just move the sin squared x to the other side, we get sin x equals 1 minus sin squared x. Now wait a minute. 1 minus sin squared x? That's our master key. That's just cos squared x. So we've just found the secret link. Sin x is the exact same thing as cos squared x. This is huge. Now we substitute. We go back to our expression, and everywhere we see cos squared x, we replace it with sin x. So, cos 4x plus cos squared x squared becomes cos x squared plus sin x squared. And now look at what's inside those parentheses. It's sin squared x plus sin x. The original problem literally told us that equals 1, so our entire expression is just 1 squared.
And the answer is 1. That whole impossible complicated mess with all those high powers, it all just boils down to the number 1. It was never about complicated calculations, it was about spotting the hidden pattern and making one critical substitution. That's the power of cracking the code.
So, let's pack our bag. Let's go over the powerful tools you've just earned and added to your official Codebreakers toolkit.
Rule number 1, the power of 1. Sin squared theta plus cos squared theta equals 1 is your starting point for almost everything. Rule 2, the conjugate trick. Remember that secant theta plus tan theta is just 1 over secant theta minus tan theta. It turns hard algebra into simple fractions. Rule 3, the special case. If a function plus its reciprocal equals 2, the function itself has to be 1. And finally, the master strategy that ties it all together. Use the clues. Always look for a way to use the information you're given to transform the question you're being asked.
That's all for this one, but it kind of makes you wonder, right? This whole mindset of looking for the simpler pattern underneath a complex surface, that's not just for trigonometry. So my question for you is, what other complex codes, whether it's in math, science, or just your everyday life, are really just simple, elegant patterns waiting for a code breaker like you to find them?